Hello everyone. So today we are going to discuss challenge yourself from D3 mathematics series from chapter 1 quadratic equations and functions. So let's start. In challenge yourself in chapter 1 we are going to have two questions, and these are about the quadratic formula, quadratic functions. So let's try to solve question 1 first, and then we will move to question 2. So let's see what does question 1 says. It says a two-digit number is such that the sum of its digits is 6 and the product of its digit is 1/3 of the original number, and we need to find the original number. What is that two-digit number? So we can take like one digit as x and the other digit could be y. So how to do it? First of all, let's recall something important about the numbers. So remember the numbers for example the two-digit numbers, so we have tens and units in it. So for example, if we have a two-digit number, I take any random number. For example, I take 53, so I can write 53 as 50 plus 3. So the right digit represents units while the left digit represents the tens. How many tens are there? It's 5. And how many units are there? It's 3. So I break this number into tens and units. So I have 50 plus 3, 5 tens and 3 units. Or I can write it down as 5 times tens, 5 tens I have, and 3 times 1, 3 units I have. So it's 5 tens and 3 units. For example, we can take another number. For example, let me write down 79. So we can see how many tens and how many units are there. There are 7 tens and 9 units. So this is going to be 7 times 10 plus 9 times 1. There are 7 tens and 9 units. So any two-digit number can be broken into tens and units. And similarly, just if we extend for like three-digit numbers, so if I write down like 235, so that means it has 2 hundreds, 3 tens and 5 units. It has 2 hundreds plus it has 3 tens plus it has 5 units. So this is how we can break a number into units, tens, hundreds, thousands, and so on. Over here we are given a two-digit number, so it means we have only two digits. We can break it into units and tens. So let's call, for example, we have x tens and let me call it y units. So the two-digit number, I can express it as 10 times x plus y times 1. We don't need to write y times 1, y is enough. So it says the sum of the two digits is 6. That means x plus y is going to be 6. And the product of the two digits means x times 1 is going to be 1/3 of the original number, 1/3 of 10x plus y. Let's write down these two conditions in the form of two equations. So I can express the first condition as x plus y is equal to 6. Sum of the two digits is equal to 6. And the second condition as product of the two numbers x times y, product of the two digits, is equal to 1/3 of the original number, and over here it's my original number, 10x plus y. So it's 1/3 times 10x plus y, 10x plus y. So I can take either x or y from here. Let me take out y. Y is equal to 6 minus x. And I can plug this value into the second condition or second equation. So I can write it like x times y. Y is my 6 minus x, and this is going to be 1 over 3 times 10x plus y. So y is going to be 6 minus x. I can multiply 3 on the other side, so this becomes 3x times 6 minus x, and this is going to be equal to 10x minus x is 9x, so let me write it down, 9x plus 6. So this is, let me multiply x inside. In fact, we can just divide by 3 everywhere. So this is going to be, if I divide it by 3, divide it by 3, or otherwise I should not have taken 3 on the other side, it's fine. So this is going to be x 6 minus x, this is equal to 3x plus 2, and let me multiply it inside. So it's 6x minus x square is equal to 3x plus 2. So this equation I can simplify it. It's going to be a quadratic equation. I can find the value of x. So I rewrite the equation. 6x minus x square is equal to 3x plus 2, right? So 3x plus 2. Let me simplify. Take everything on one side. Let's keep x as positive. So x square minus 6x plus 3x plus 2. So x square minus 3x plus 2 is equal to 0. We can easily factorize it. It's going to be x square minus x minus 2x plus 2 is equal to 0. So it's x, take it common, is x minus 1, and minus 2 comes as common factor, so it's going to be x minus 1 is equal to 0. So x minus 2 times x minus 1 is equal to 0. So we can have x is equal to 2 or x is equal to 1, either of these things. And let's see what will be the value of y. So I write it down over here. So our y is equal to 6 minus x. So y is equal to 6 minus x. If x is true, so I'm going to get y as 4. So my number is going to be 24. And if x is equal to 1, in that case y is going to be 6 minus 1, which is 5. So my number is going to be 15. So these are the two possible answers I can have. We can check it. So the sum of the two digits should be 6. So 2 plus 4 is 6, 1 plus 5 is 6, and 1/3 of the number, if we multiply these two numbers, it should be 1/3 of the original. If we multiply 2 times 4, it's going to be 8. 8 is 1/3 of 24. So the second condition is satisfied here. And if I take 1/3 of 15, it's going to be, if I multiply 1 and 5, it's going to be 5, which is 1/3 of 15. So it means over here condition is satisfied. So both these answers are correct. It satisfies our given equation. So we solve this challenge 1. Okay, let's move to challenge 2. What does it say? It says if x is equal to h and x is equal to k, it means we have two roots, x is equal to h and x is equal to k, and these are the real solution, real roots of a quadratic equation, our standard form equation, ax square plus bx plus c, where a, b, c are constant, is not equal to 0. We say that x is equal to h and x is equal to k are the roots of the equation. The sum of the roots h plus k and the product of the root hk can be expressed in terms of the coefficients a, b and c. Find an expression for h plus k, sum of the roots, and the product of the roots hk in terms of a, b or c. Let's try to solve it. So we know ax square plus bx plus c is equal to 0. It gives us, we can find solution in 3 different ways, which we study in our text, like quadratic formula or by factorization or by completing the square. We will look at like quadratic formula solution and factorization. So, and we are given the roots. So x is equal to h and x is equal to k. These are two roots. So we can write it down like x minus h times x minus k. So these are the two factors of our quadratic equation. If we multiply it, I mean, we are doing the reversing. Instead of factorization, from factorization we are going to write the standard form of the equation. So x square minus hx minus kx plus hk is equal to 0. So we can write it down in terms of like we take minus common, x square minus h plus k x plus hk is equal to 0. So this is a beautiful form of the equation because it gives me hk and it gives me h plus k, which I'm going to find out in terms of a, b and c. Let me call equation 1. Now let's look at this one, ax square plus bx plus c. What will be the roots of ax square plus bx plus c is equal to 0 in quadratic form? So we know the roots are x is equal to minus b plus minus b square minus 4ac divided by 2a. So these are the two roots, one with the plus sign, one with the minus sign. If these are the two roots, can we write it in the factorized form? Why not? So I can write it down like x minus first root times x minus the second root. And first root is, let's suppose I can take it with the plus sign over here, and the second root I can take it as minus sign. So let me write it down, and we can then multiply it and try to simplify it, and then we will compare it with equation 1. So it's going to be x minus so minus and the minus of the root, it will become plus. So x plus b over 2a, I separate 2a with b and b square minus ac, and then we have plus. So plus b square minus ac, because of this minus sign this will become minus. So minus b square minus 4ac and divided by 2a. That's fine. Let me close the bracket, and then I write it down the same expression but with negative sign of our discriminant term. Discriminant term is b square minus 4ac. So with the negative term, because I have negative outside, so it will become a plus sign, plus b square minus 4ac and divided by 2a. So over here I simply rearrange some of the terms. I take x plus b over 2a as my first term. Let me write down 1 over here, and take b square minus 4ac over 2a as my second term, and then I will apply the square of difference formula. Recall, we have a square minus b square is equal to a minus b times a plus b. So if we have difference of two square term, we can write it down as a minus b times a plus b. So over here, so this is my a term, x plus b over 2a, and b square minus 4ac square root over 2a is my b term. So it become like a minus b times a plus b. So I can write it down as a square minus b square terms. So the first term square and the second term square. Let me write it down. It will become a little bit long expression, but then it will simplify very beautifully. So I can write it down, the first term square, x plus b over 2a whole square, minus the second term square. So it is going to be b square minus 4ac divided by 2a, and this term square is equal to 0. Let me expand it on next slide. So it's going to be x plus b over 2a whole square minus b square minus 4ac square root over 2a. I can expand over here, so it's going to be x square plus a plus b whole square formula. I am going to apply x square plus 2 times b over 2ax plus b square over 4a square, 2a square by 4a square minus square of this thing. So this is going to be b square minus 4ac divided by 2a. I am divided by 2a square, so it's going to be 4a square. So b square over 4a square, and I am writing 4a square over here as well. So let's cancel the term which can be cancelled. B square over 4 square is cancelled with minus b square over 4 square, and over here we can cancel 4 by 4 and a with a square. Let me write it down here with tidy way. X square plus I get bx, and then I get minus c over, sorry, I get b over ax, and then over here is minus 4ac over 4 square. 4 is cancelled, a in denominator is cancelled, so I get minus c over e. So this is what I get. So this is the quadratic equation I get from the factors of quadratic formula. This is going to be equal to 0, and let me call it equation 2. And what was my equation 1? My equation 1 was x square minus h plus kx plus hk. So it means I can compare coefficients of equation 1 and 2. So compare coefficients of equation 1 and 2. So we can see minus h plus k, that was coefficient of equation 1 with x. So this is equal to b over a. That means h plus k, sum of the two roots, is equal to minus b over a. So this is a good result I have got. And the product of the two terms hk, so this is my free coefficient term. In equation 1 I had got hk, in equation 2 I have got minus c over e. So this is the product of the two terms. So sum of the two terms is minus b over a. Product of two terms is hk is equal to minus c over a. And in particular equation, if a is equal to 1, so then h plus k is going to be equal to minus b. If a is equal to 1, so hk is equal to minus c. So these are the two challenges that we had from D3 chapter 1. These are solved. Our cuddly curious cat is happy and it has become chubby now.